All right, guys, so we're gonna have to go with plan B. We kind of had a marker malfunction, so we're gonna go with it like this on paper. Couple things to keep in mind. For some reason, my attendance didn't save on Sunday, so it looks like you all are marked absent for last week. That should be fixed tomorrow, hopefully. Second thing, what was I gonna say? Oh, if you are turning in work late, please email me to let me know that you turned in work late, because I get like 100 notifications a day on Schoology and sometimes I just can't sort through them. All right, so this is going to be our last actual new lesson this week. It's about simplifying radical expressions. So when we think of a radical, what do we think of? We think of a square root. So square root, this is called a radical. Okay. This is a radical because it's a radical symbol, and this is a square root because there's no number here. So like, for example, the square root of 25 is 5. The square root of 36 is 6. The square root of 100 is 10. And you all know that. That's a skill that you all should have from previous years. A skill that you all do not have is simplifying radicals that are not perfect squares. So what do I mean by when I'm saying perfect squares? I'm talking about numbers that have been squared. So for example, 1 squared is 1. 1 is a perfect square. 2 squared is 4. 4 is a perfect square. 3 squared is 9. 9 is a perfect square. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225, and that's about where I lose having them memorized. All right, simplifying non-perfect squares. Okay, what you're going to be looking for is for one of these perfect squares, so this column right here, you're going to be looking for one of these perfect squares to go in there an even amount of times. So we'll start with something pretty simple here. The square root of 18. Okay, if you square root 18 on your calculator, you get a decimal. I am repeating, you should not give me decimal answers. If you give me decimal answers, you get a 0. We are not doing decimals. All right, I said that very firm. I'm serious, okay? So what you're looking for is for one of these perfect squares to go in here an even amount of times. And you're always looking for the largest perfect square that goes in there. So the first one that's smaller than 18 is 16. 18 divided by 16 is a decimal. Then I go to the next one that's smaller. 18 divided by 9 is 2. So I'm going to rewrite this to be 9 times 2. Because 9 times 2 is 18, and 9 is the perfect square that goes in there an even amount of times. Now, you're going to square root the perfect square. So what is the square root of 9? The square root of 9 is 3, so that comes out of the root. I don't know what the square root of 2 is, so I'm going to leave it in the root, and then I would be done. All right, let's look at another one. The square root of 48. All right, so I'm going to start with the first one that's smaller than 48, which is 36. So on your calculator, 48 divided by 36 is a decimal. Go to the next number. 48 divided by 25 is a decimal. 48 divided by 16 is 3. So I'm going to rewrite this to be 16 times 3. What is the square root of 16? The square root of 16 is 4. So this will be 4. And then I can't square root 3 because 3 is not one of these perfect squares. So it stays under the root. So 4 square roots of 3. There was a couple of you all that did that on your homework for quadratic formula. And I know that you got it from an app or from somewhere because you hadn't learned this skill yet. All right, let's do another one. Let's do the square root of 160. All right, so the first number that's smaller than 160 is 144. 160 divided by 144 is a decimal. 160 divided by 120 is a decimal. Decimal, 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 decimal. The first one that goes in there an even amount of times is 16. Some of these are pretty obvious. Some of them are not. So sometimes it's going to take you a little bit longer. So 16 times 10 is 160. What is the square root of 16? 4. Is 10 one of these perfect squares in this box? Nope. So I leave it under the root. All right, let's do another one. The square root of 72. All right, so I go to my list of perfect squares. The first one that's smaller than 72 is 64. 72 divided by 64 is a decimal. 72 divided by 49 is a decimal. 72 divided by 36 is 2. So I'm going to make this be 36 times 2. What is the square root of 36? It's 6. But I don't know what the square root of 2 is because 2 is not a perfect square, so I leave it under the root. Okay. Let's do the square root of 54. All right, so the first one that is, hopefully that didn't pause it because my battery's low. The first one that's smaller than 54 is 49. So 54 divided by 49 is a decimal. 54 divided by 36 is a decimal. 54 divided by 25 is a decimal. 54 divided by 16 is a decimal. 54 divided by 9 is 6. So that's going to be 9 times 6. And I always am writing the perfect square first. All right, what is the square root of 9? The square root of 9 is 3. I don't know the square root of 6 because 6 is not one of these perfect squares in this box, so it stays under the root. All right, we'll finish with one more. Let's do the square root of 50. All right, so the first one that's smaller than 50 is 49. So 50 divided by 49 is a decimal. 50 divided by 36 is a decimal. 50 divided by 25 is 2. So that's 25 times 2. Well, what is the square root of 25? It's 5. I don't know the square root of 2, so I'm going to have to leave that under the root. So it's 5 square roots of 2. All right, so I'm going to give you a few practice problems tonight on this. I need to see this step right here. I want to see this work. Okay? All right, let me know if you have any questions. Adios.